Welcome to Swagelok, Indiana, Cincinnati's valve selection webinar. Our presenter today will be Mike Peckrell. He is our field engineer. Please feel free to chat with Mike, send him a message, or you can send me an email and we'll get those questions to Mike. Please remember to turn off your camera to ensure optical webinar sound and quality, and also mute. If there's any questions, if you have any questions, please let me know, and we'll go ahead and turn it over to Mike.
All right, thank you very much, Sherry. Hello, everybody. Today we're going to do a valve tech talk, and this is meant to be a high-level discussion on valves, obviously. So we're going to talk about the types of valves. We're going to talk about rating of valves. What is CV? And we're going to talk about the different types of valves: ball valves, needle valves, Bellows valves, and check and relief valves. And also we're going to briefly touch on working with oxygen and the issues with that. So common valve types, ball valves, butterfly valves, there are a lot of different types of valves out there. They can range from small, 1/8 inch, up to several feet in diameter. For purposes of this discussion, we're going to stay under 2 inch and under. But I'm sure you've seen all these types of valves before: ball valves, butterfly, glow valves, plug valves. And the different functions and different symbols out there. So on, off, flow control, directional control, or check, or a check valve, overpressure protection, relief valve, excess flow protection. So what is CV? So the flow coefficient of the valve is a relative measure of its fluid flow. And so in this case, water, it's pressure drop of 1 psi, expressed in gallons per minute at 60 degrees temperature. So for compressible fluids like gases, calculating and using CV is a little more complicated. And here are some gas formulas. Gases are compressible and they are affected by temperature. So there's two different formulas. There's the estimate gas flow. There's the upstream, when the upstream pressure is greater than 2 times the downstream pressure. There's known as choke flow or sonic flow or critical flow. And it calls for a different formula. And how it is measured is in its simplest form is like this. So it's a pressure drop across an orifice. In the real world, you have a valve would have different changes, different diameters, different directions of flow. And so how do they test that? There's a standardized test out there. Valve manufacturers test the valve to determine the flow coefficient, and that's what they publish in their catalogs. So ball valves. As the name implies, a ball is a sealing mechanism. These are on and off. They are not meant to throttle. They are not meant to be used for flow control. As you can see, the advantage is there's almost no restriction through a ball valve. It's basically straight through. The advantage of the ball valve: high flow, quick response, durable. There's many different handle options. You can easily automate it. Easily maintenance. Usually they're rebuildable, some are not. Typically they come in different port sizes, different port options, NPT, pipe thread, weld, tube fittings. Troubleshooting on a ball valve. Typically, if there is a leak, it'd be through the stem. There would be a procedure, usually it is to tighten this stem, and you would compress the valve packing, and therefore seal any leak that may come up through the top here. Different handle options are available out there for ball valves. Locking, oval handle with lock. It's almost like dozens of different types. Extended handles are available, and this to allow easier access to a valve when there's an obstruction, such as insulation on the plumbing. And so the handle would stick above that, so you could easily operate the valve. Ball valves, they are easily to automate. So you can have electric, pneumatic. You can have actuate. So the actuators would actually operate the ball valve for you. Electric actuators, convenient, just give it electricity. Disadvantages, limited in power. Usually there's only so much torque a electric actuator can produce. Typically those electric actuators can give a output signal as to the actual position of the ball valve. So you don't need to physically look at it. You get a signal back to your control room what position the ball valve is in. Pneumatic actuators, let's see here. If I can, real simple, it's using air instead of electricity. You supply air to the actuator, it moves rack and pinion, moves the rack, rotates the pinion, and operates the ball valve. In this case, you have a spring for normally closed or normally open. So if you take away air, the valve will automatically retract and go back to its original position. You can also get this not just in ball valves, but in all other types of valves too. In this case on the left is a Bellows type valve, but just has a piston on top and to operate it pneumatically. Electropneumatic actuators, kind of the best of both worlds. You can control a valve with electrical signal, but have the power of a pneumatic actuator. In this case, they're showing a solenoid valve right here, and it's actually directly attached to the pneumatic actuator. So provide electricity and air to the solenoid valve, and that will provide air to your actuator. In this case, these are showing limit switches on top of the actuator that will give you an output signal as to the actual position of the valve. And in some cases, there's actually a visual indicator here to show you where open or closed, if the valve is open or closed. Needle check and relief valves, a section on this. So needle valves, so here's a kind of way of a needle valve. So it's a multi-turn valve. So you notice the stem here is shaped like a ball rather than a needle. And this is meant to provide leak tight shut off. So needle valves are available with different stem geometries, include V or regulating tips that allow for better control of flow. And here's an example of some regulating stem tips. So the primary function of needle valve is to regulate flow. So these stem tips allow that. Flow will be determined by the orifice size, stem type, stem position, but it's controlled by turning the handle. An all metal stem tip can regulate flow, but does not provide a good shutoff, especially in the gas application. Soft seat stem can regulate and provide seal when shut. Troubleshooting. So if you have a multi-turn valve and you're expecting it to regulate flow, closer look at the valve. It may be a ball stem tip where it maybe regulates a little bit, but not quite what you're expecting. The reverse can be true if you're regulating, but you're not getting leak tight shut off, especially in the gas application. So you may be an all metal or it may be a ball stem tip. So another type of flow control, which is much more accurate, is a fine metering valves. These valves are, they're characterized by a small orifice size, thin needle, a more pronounced glow pattern right here. These valves are typically found in laboratory environments where high precision control is important. important to note that these types of valves are not meant to be shut off. Usually if you try to crank down too much on it, it may damage the stem. So in your setup, you may need a separate valve for on-off. Vernier handles are also available for repeatable flow adjustments. Some specialty valves out there. So a cross pattern valve, you have flow in between the right and left here. You have across, but it is metered up to the bottom and meters to both sides. A double pattern valve, where you have a valve with two handles, and the inlet is set for a maximum flow, and the second outlet can be used for that fine metering flow control. Bellows valves, not spend too much time on this, but Bellows valves, they're similar. See, the metal form here, Bellows, to provide a reliable seal to the atmosphere. If you're using corrosive gases, leakage to the outside is difficult because it's obviously sealed by this Bellows. You're not relying on any elastomers for sealing. Elastomers are susceptible to attack, especially with corrosive gases. Also, depending on the application, oxygen, moisture is difficult for oxygen moisture to leak into the valve and affect any fluids or processes you may have going on. Sniffer tubes are available for this, and this is to give you a monitor of the integrity of the bellows, especially if it's an acid or corrosive gases. This can give you a little warning if this bellows has failed. The advantages of bellows are very clean, used for clean applications, very low leak rate, and you can automate it with a pneumatic actuator. Just like needle valves, you have different stem tips available, regulating and shut off. It's very similar to a multi-turn, and it can, like I said, give you some regulation for flow control. Diaphragm valves, as the name implies, very simple mechanism. Diaphragm is used for the sealing mechanism. It's an on and off application, usually used in high purity environments. Simple construction, easy repair, minimal particle generation is created just because it's just a diaphragm. There's nothing else really there. Check valves and relief valves. Okay, so check valves. It's meant to provide fluid flow in one direction only. Close fast enough to prevent any reverse flow. They're meant to stay open. They're similar to a relief valve, like I said, but they are different. So it's meant to stay open and meant to just, like I said, for fluid direction, for directional fluid, one direction only, excuse me. Check metal, all metal check valves are out there. Advantage of these are no elastomers, very high temperature rating. This little check here is closed by gravity. In the high temps around a 900 degree F range. So relief valves, like a check, the poppet is controlled by a set spring. But relief valves are meant to be closed, meant to stay closed, and only open at a predetermined set pressure. So this is an example of a proportional relief valve. So out there in the world, you see proportional relief and you have safety relief. So proportional relief, as the pressure exceeds the set point, it opens gradually, does not have a capacity rating. Safety relief conforms to a standard. So it's characterized by rapid opening. And how that's done is that you, on the right here, you have a higher pressure and you're exceeding your set point. Typically, this over here would be atmosphere. So as this opens, you have more surface area on this popping. Surface area times pressure equals force. So as this cracks open, you get more force, more surface area exposed, and it will force this safety valve open, all but 100% open. Well, I want to touch on working with oxygen and some safety things to keep in mind when you're working with oxygen. Oxygen in itself is not flammable. It doesn't burn, but it makes everything else very flammable, especially in high pressure and high concentration of applications. They make materials more likely to burn, including metals like stainless steel. So in general, working with oxygen, there's always caveats, but in your system, especially if you're above 200 psi, you want to avoid working with ball valves. You want to work with needle valves that have the stem packing below the adjust screw. And the reason being, the adjust screw can contain grease, create particles when it's adjusted, and those particles can be easily ignited in an oxygen system. Your system should be clean. There are some standards out there, one of the ASTM G93. If you do need a lubricant with a lubricant that has a high ignition temperature, Krytox, for example, 427C. Valve seats, you want something that has, again, a high ignition temperature, Teflon, PCTFE. And you obviously want your, like I said, you want your system to be clean. Don't need excess dirt or any particles inside your tubing or inside your fittings. And so the reason why to avoid a ball valve in a high pressure, high oxygen concentration system is that the ball valve is quick acting. So oxygen is introduced to the inlet port, and it's a quick opening valve. That valve pressure comes on down the tubing at that sonic flow, and it meets an obstruction. Well, then it could ignite that obstruction, especially if it, exceeds the temperature of the auto emission point. So that is one reason why to avoid a quick opening ball valve in oxygen systems. And I went through that a little more quicker than I thought I would. Is there any questions out there?